So in this lecture, we're going to take a very similar step to what we took in the previous ones, and we're going to look for ways to find the integrals of powers of the secant and tangent functions. And the techniques that we use here with the secant and tangent, you can use the exact same things to do integrals involving the cosecant and cotangent. And the methods we use here are going to be similar. We're going to rely heavily on trigonometric identities, specifically the Pythagorean identities for cotangent relating cotangent and secant and cotangent and cosecant, and we're going to rely on substitutions, trig substitutions. So how can we do this one, for example, the tangent to the fourth dx? Well, I'm going to start by rewriting this in a very similar way to what we've done before. I'm going to make this the integral of tangent squared x times tangent squared x dx. Okay, now I'm going to use one of those Pythagorean identities. I'm going to make this the integral tangent squared x times 1 minus secant squared. Excuse me, got that backwards. Secant squared x minus 1 dx. And now I'm going to break a little bit with what we did before. Right? In the past, when we got to this point, this is where we looked for a trig substitution. For a trig function, we could use to do a u substitution. What I'm going to do here is I'm going to distribute into the parentheses. And I'm going to let this become the integral of tangent squared x secant squared x minus tangent squared x dx. And now I'm going to split this. Right? I'm going to split this into two integrals. I'm going to make this the integral tangent squared x secant squared x dx minus the integral of tangent squared x dx. Okay, now our paths really are going to start to diverge here. Okay, with this first part, I'm going to do a u substitution. Right, with this first part, I'm going to let u equal the tangent of x. So du is secant squared x dx. And that makes this integral the integral u squared, and secant squared dx, that's du. Excellent. This is u to the third over 3. I'm not going to worry about the constant right this second. I'm just going to stick one big constant on at the end. So now if I put the tangent back in here, this is tangent cubed x over 3. Okay, good. Now, how about this part? Right, well, over here, I'm going to make this the integral of, and I'm going to do this trig substitution again. Secant squared x minus 1 dx. All right, let's split this into two integrals. This is minus integral secant squared x plus the integral of dx. And I know these. The integral of the secant squared, that's the tangent. So this is minus tangent of x plus the integral of dx is just x plus that long-awaited constant. Right? So there's our integral. Okay, so there's some similarities. We had some u substitutions. We relied twice on the trigonometry's Pythagorean identities, but there were some twists, right? We didn't just go for the substitution and then go straight to the integral. We had to split it up, right, and handle the parts individually. So how about this one? Well, here's what I'm going to do. I'm doing something very similar to what we did with the sines and cosines. I'm going to pull off a secant and a tangent. So this will be the integral of the secant x times the tangent of x times tangent squared times secant to the third dx. Okay, and hopefully you can see the direction I'm thinking about going with this, right? Because I pulled out a secant tangent, and that is the derivative of the secant, I'm really looking to make that my du. All right, so if I let u equal the secant of x, then du equals the secant of x times the tangent of x dx. Now at this point, I've committed. I need to get any tangents other than the one that's going to go into my du. I need to get all the other tangents out of there so that all I have are secants. Okay, so how am I going to do? I'm going to use the Pythagorean identity here. This is the integral secant. I'm going to stop writing the x's here. Secant tangent times secant squared minus 1 times secant cubed dx. And now I'll make my substitution. Secant tangent dx, that becomes du. And I'm going to put u in here for the secant. So this is the integral of u squared minus 1, u to the third, du. And now it feels a lot like the sine and cosine ones. Now it's just a polynomial. So this is the integral u to the fifth minus u to the third, du. That's u to the sixth over 6 minus u to the fourth over 4 plus the constant, and now just substitute back. Secant to the sixth x over 6, whoops, not plus, minus secant to the fourth x over 4 plus a constant. So we've got one more topic that we're going to talk about in this chapter. And it's going to be methods for evaluating integrals like this one here, where you have the cosine and sine of multiples of x rather than just the straight sine and cosine.